Class 11 Mathematics, NCERT New Delhi and COHSEM Manipur. Unit 2 Algebra. Topic Complex numbers and quadratic equations. Subtopic Representation of a complex number by a point in a plane. ARGAND diagram. Modulus and argument or amplitude of a complex number. Polar representation of a complex number. Exercise 5.2. Argand plane. The complex number x plus iy is represented by the unit point xy in the xy plane. Complex number x plus iy haibasi xy plane da xy haiba order pair asina mahut sili. The x-axis and the y-axis are called the real axis and imaginary axis. X-axis asibuna real axis kawi because every purely real number represented by a point on this axis, and the y-axis is called imaginary axis because every purely imaginary number is represented by a point on the y-axis. The plane representing a complex number by point is called Argand plane or complex plane. Point complex number amabu mahut siliba point asi bu represent tauliba plane adubu aikoina Argand plane natraga complex plane kawi. Every complex number is represented by a point on the Argand plane. Complex number khudingmak Argand plane da leiba point amana mahut sili. Conversely, every point on the Argand plane represents a complex number. Every Argand plane da leiba point khudingmak asigisu corresponding complex number ama lei. The modulus of a complex number that is z equal to x plus iy is modulus of z equal to modulus of x plus iy, which is also equal to square root of x square plus y square. This quantity, which is the distance between the point P whose coordinates are x, y and the origin O whose coordinates are 0, 0. Any complex number amagi modulus haibasidi complex number dubu represent over point aduga origin ga anigi arapa dubune. Polar representation of a complex number. Polar representation of a complex number. Complex number amabu polar representation. Let P whose coordinates are x, y represent the complex number z equal to x plus iy on the Argand plane. P hariba coordinate x, y oiba asina complex number z pu Argand plane da mahut silasi as in this picture. Let OP, distance between O and P is equal to R, which is modulus of Z, and angle POX, asibuna theta loxelasi. The order pair R theta will locate the position of the point P. Mathamonau naiba jura R theta asina point P gi leifam takpa ngame. Call polar coordinates of the point P. Point P gi polar coordinates sinkawi. From right triangle OPN right triangle asidagi we have ON habasidi OP cos theta ne ON by OP the base by hypotenuse the cos theta ne, and the PN habidi perpendicular the OP ni yalabadi opposite by hypotenuse the sin theta ne. Therefore we have ON equal to OP times of cos theta and PN equal to OP times of sin theta. ON is replaced by X, OP is replaced by R. We get X equal to R cos theta, and ONPN is replaced by Y. OP is also replaced by R. Therefore, we get Y equal to R sin theta. Therefore, Z equal to X plus IY. X की value the R cos theta ni, Y की value the R sin theta ni. Madu sinjilaba matungda term animaktagi common factor R logthokrabadi we get R times of cos theta plus I sin theta phangi. This is the polar form of the complex number. This x plus iy is equal to r times of cos theta plus I sin theta. This expression is called polar representation of the complex number z. Here r is the modulus of z denoted by modulus of z, and theta is argument or amplitude denoted by arc z or amp z. The argument of z natraga amplitude of z haina pagani. Thus, modulus of z is equal to r and argument of z is theta. R asibuna modulus of z khangna, argument of z haragadi theta asibu khangna gani. the value of theta such that minus pi less than theta less than or equal to pi is called principal argument. Theta की value ना minus pi दी नतबा plus pi फावा सिगी मरक्ता लेबे angle अमा ओरबदी मधुबु complex number दुगे argument principal argument कवी. Exercise 5.2. Find the modulus and the argument of each of the complex numbers in exercise 1 to 2. 1 dagina 2 फावगी complex number singa sige modulus amasung argument sing putu u. 1 z equal to minus 1 minus I root 3. Let z equal to minus 1 minus I root over 3 is in the form of r times of cos theta plus I sin theta. Equating real and imaginary parts we get. For real part right side की दी r cos theta ने जो left side की दी minus 1 and imaginary part अनि से compare तो रबदी for right side की r sin theta ने for left side की minus root 3 ने. Squaring and adding we get this equal to minus 1 square plus minus root 3 whole square whose square is 1 whose square is 3 which makes for 4. R square comma log the cos square theta plus sin square theta equal to 4 can be written as 2 square. Cos square theta plus sin square theta d1 this give r equal to 2 because r should be positive. It is the distance between 2 points. Therefore modulus of z is 2. That is the value of r. Again r sin theta by r cos theta we get dividing these two equations we get this whose value is tan theta which is the root 3. Tan theta is root 3 which tan of which angle gives root 3. There are many angles but we have to find out the point representing the complex number lies minus minus, that is in third quadrant. Tan theta equal to tan of minus 2 pi by 3 because the point this lies in the third quadrant lerabadi pi plus la arrow minus pi da lakani haibadi third quadrant represent toragadi. Let us see. Point ama represent torabadi sigi complex number si som da lakpa angle sina orani som da lakpa angle asidi not or masidi oito or theta ki value the som da orani sina x axis ne sina y axis ke positive direction ne sina origin ne. Therefore minus twice pi by 3 orani that is minus 120 equating theta equal to minus 2 pi by 3. This is the argument. Therefore argument of z is minus 2 pi by 3. Haribe angle asi amuk su ningsingba yai aikoina theta ki value si minus pi ki marakta laigadabani haiba masu hai kare. Pi marakta laigadab si ki marakta laigadab. For question number 2, let minus root 3 plus I equal to r cos theta plus I sin theta. Equating real and imaginary parts from both sides we get r cos theta equal to minus root 3 and imaginary part r sin theta equal to 1. Squaring and adding we get this which gives r square equal to this is r square equal to 2 square gives r equal to 2. Therefore modulus of z is 2. Also r sin theta by r cos theta is 1 by minus root 3, that is tan theta equal to minus 1 by root 3. Tan of which angle gives this because the point representing the complex number lies in the second quadrant. The complex number will represent over point adu second quadrant later. Second quadrant later the angle do from the lower from the count or theta to from the count or. Therefore there is pi mahaki pi kan putokana si pi yaru matung das tahalak patok haidokani. There is pi minus pi by 6, that is 10 of pi by 6. Since minus 3 1 lies in the second quadrant, equating this theta equal to pi by 6, there is 150. 150 is lying between this 150. Since this 150 is lying between minus pi, this 150 is lying between these two numbers. Therefore argument of z is pi by 6. Convert each of the complex numbers given in exercise 3 to 8 in polar form. Question exercise 3 dagin 8 power ki complex number singa si polar form the phong do u. Let z equal to 1 minus I equal to r times of cos theta plus I sin theta. Equating real parts, we get r cos theta equal to 1, and imaginary parts, we get r sin theta equal to minus 1. Squaring and adding, we get this, and which gives r square equal to 2. That gives r equal to root 2. Also, dividing r sin theta by r cos theta equal to minus 1 divided by 1, we get tan theta equal to minus 1. Tan of which angle gives minus 1? Tan of minus pi by 4. Because the point representing the complex number, lies in plus minus. The point representing the complex number lies in 4 quadrant. Therefore, we have to take minus pi by 4. Equating theta equal to minus pi by 4. Therefore, 1 minus I equal to, put the value of r, that is root 2, times of cos of minus pi by 4 plus I times of sin of minus pi by 4, which is the required polar form. 4. Let minus 1 plus I equal to r times of cos theta plus I sin theta. Equating real and imaginary parts, we get r cos theta equal to minus 1, and imaginary parts, we get r sin theta equal to 1. Squaring and adding, we get r square equal to root 2. Also, dividing r sin theta by r cos theta equal to 1 by minus 1, we get tan theta equal to minus 1. Tan of which angle gives minus 1? The point minus 1, 1, representing the complex number, lies in the second quadrant. Complex number sibu represent over point asi second quadrant lay. Second quadrant lay rabadi angle do principal argument phonana baswam the gilogani. Point do represent over do. There is pi yaruga return pi by 4 hydrochloride. That gives tan of 3 theta equal to 3 pi by 4. Therefore, minus 1 plus I can be put in the root 2 times of cos of 3 pi by 4 plus I times of sin of 3 pi by 4, which is the required polar form. Convert each of the complex numbers given in exercise 3 to 8 in the polar form. 5. Minus 1 minus I. Let minus 1 minus I equal to r times of cos theta plus I sin theta. Equating real parts, we get r cos theta equal to minus 1, and equating imaginary parts, we get r sin theta equal to minus 1. Squaring and adding, we get 2. Taking out r square root, we get r equal to root 2. Also, dividing, we get r sin theta by r cos theta equal to minus 1 by minus 1. That gives tan theta equal to 1. Tan theta. The point representing the complex number lies in third quadrant. Therefore, we have to take third quadrant rabadi. Complex number sibu represent over point do third quadrant rabadi pi yaruga return torakane. Minus pi return torakani, mahakna halakadabasi pi by 4 ni. That gives minus pi plus pi by 4. Equating theta equal to minus 3 pi by 4. Therefore, minus 1 minus I equal to r the root 2 pichilo theta की value minus 3 pi by 4 pichilo, which is the required polar form. Number 6. Minus 3. Minus 3 can be put in let minus 3 equal to r times of cos theta plus I sin theta. Equating real parts, we get r cos theta equal to minus 3, and the imaginary parts, we get r sin theta equal to 0. Squaring and adding, we get r square. R is 3. Also, dividing r sin theta by r cos theta equal to 0 by minus 3, that gives 0. That gives tan theta equal to 0, which is 10 pi. Equating theta equal to pi. Therefore, minus 3 can be put in the form, put r value to 3 thamo pi theta value to pi thamo, which is the required polar form. For number 7. Let root 3 plus I equal to r times of cos theta plus I sin theta. Equating real and imaginary parts, we get r cos theta equal to root 3 and r sin theta equal to 1. Squaring and adding, we get r square equal to 2 square. That gives r equal to 2. Dividing r sin theta by r cos theta equal to 1 by root 3, we get tan theta equal to 1 by root 3. The point root 3, 1 representing the complex number lies in the first quadrant, therefore which is 1 by root 3 is 10 of pi by 6. That gives theta equal to pi by 6. Therefore, given complex number root 3 plus I can be put in the form of 2 times of cos of pi by 6 plus I times of sine of pi by 6, which is the required polar form. For question number I, let I equal to r cos theta plus I sin theta. Equating real and imaginary parts, we get r cos theta equal to 0 and r sin theta equal to 1. Squaring and adding, we get r equal to 1. Also dividing, we get r sin theta by r cos theta equal to 1 by 0. Implies tan theta is infinity. What will be theta? Theta will be pi by 2. Therefore, I can be written as 1 times of cos of pi by 2 plus I times of sine of pi by 2, which is the required polar form. Thank you for watching video.